Hello in CCI Security series. In this lesson we will talk about Dmvpn. You guys, as you remember, in the last video we were talking about GRE. Do you guys remember what the GRE was for? GRE was, as you have here, one site and the internet here and the other site. We connected these two sites together by GRE. We created a tunnel interface over here, as well as we created a tunnel interface over here. But this solution is not scalable. Why? This is, if we have a small number of sites, is gonna be good. But what if we have multiple sites? If we got another branch here, if we got another branch here, and we need all these sites to talk together. In GRE, if it is small number of sites, so it's gonna be good. But in this case, it will be a hindrance. So we will use Dmvpn or MGRE. MGRE, we will use a tunnel interface. Okay, we will use a tunnel interface, and the tunnel interface itself is gonna be in MGRE mode. And we will do it same like hub and spokes. These are spokes. And this is the hub. We will let this spoke connect to the hub. And with the development of Dmvpn, we'll get note that Dmvpn started with connecting the spokes to the hub, and in phase 3 of Dmvpn, as we will know later, that the spoke will talk to each other directly by tuning the phases of Dmvpn, the performance of Dmvpn. So let's go to the lab here over here in the Genius 3. I created these sites as you see here, and we can call it, for example, this is Dubai, as we used to do, and this is, for example, this is Cairo. Here is, for example, Kuwait. And here is for example New York. If we have sites like this actually, and we want to connect all of them together, MGRE is a suitable solution in this case. So let's see how we configure it. But before I do it, let's show the lab, or explain the lab how it's connected. As you see here, this is router 1, which is acting as a obey. This connecting this router 5 in the middle. This router 5 is acting the internet. There is static route or default route in all of these routers. That the next hub is router 5. For example, I will show you here. Show running config section IP route. You will see that there is a default route. Yeah, this is my default route here. The next hub is router 5. So all these routers has the same default route, is referring to this. So I have connectivity between the public IPs. Yani if you are in Dubai, router 1, and you want to ping Cairo 192.120.2, you will be able to ping. You will be able to reach it. But what about the private network that located in Cairo? Can I reach it? Let's see. I will ping it. Ping 10.3.1.3. I want be able to reach it. Okay. Once I create the VPN or Dmvpn between these sites, I'll be able to ping. Okay. This is going to be the first step to create the tunnel, to create the connectivity between the sites, and the next step after that will use IPsec to encrypt the data. So let's go and do this configuration and see how it is get done. So first we'll create the tunnel itself, tunnel interface tunnel 1, and I'll give it an IP address 192.168.1.1. This is the IP of the tunnel, and as we know from the last video that there is a source and destination, right? Tunnel source is 192. You guys remember what? The public IP, which it is the outgoing, yeah. For the outgoing interface here. We can use the interface itself, yani instead of mentioning the IP, we can mention the interface. So tunnel source 192.1, what is the IP here in the head office? It is 1.10.1. This is the source. What about the destination? Shall I write the destination here? No, because we are talking about here, guys, because we are talking about Dmvpn. But let's put the mode first. Tunnel mode, in this case, is what? The tunnel mode is what? Tunnel mode is GRE multi-point. Here, what about the destination? Why I didn't mention the destination here? I'm gonna mention it, but we have something called NHRP. NHRP. This is a protocol used with Dmvpn just to map, in order to map between the real IP and the IP of the tunnel interface. Like for example, I have the tunnel interface located here on this router, T1 interface. What is the IP? It's 192.168.1.1. This is the IP of the tunnel interface. What about the outgoing interface here? What is IP here? 192.168. Sorry. 192.1 dot what? Dot 10.1. This is the real or the public IP over here, and this is the tunnel interface IP. The NHRP is doing what? Is doing mapping between these two IPs. It's mapping already between these two IPs. How it is? Let's see. I will say IP NHRP map IP NHRP map. But first, before I do the mapping, I say IP NHRP network ID. I'm gonna give it ID 1. IP NHRP map. I'll map what? I'll map what? In the database of the NHRP, I'm gonna keep the mapping between the other sites, outgoing real IP or public IP, and the tunnel interface IP. Do you guys got what I say? Okay, and for example, IP NHRP map for router 2 or for Cairo is what? I'm using here, I'll use the tunnel interface 1, and I'm gonna give it the IP 192.168.1.2. This will be the IP of the tunnel interface. And what is the public IP here? It's gonna be 192.120.2. So I'll do the map. I'll write the map here manually. IP NHRP map 192.168.1.2, and the real IP for this site is what? Is 192.1.20.what.2. Okay, what about this site, New York? Very easy. Same. 1.3, and what is the public, the outgoing? The real IP here is 192.1.30.what.3. I did the map. I have the database right here on the in NHRP. Yes. By that, we end the configuration over here on the Dubai. Show IP in HRP if you need. You will find that you will have a channel 1 static flag, and as you see, it's multiple broadcast interface. These are the other side as you see here. Fine. Now let's go to the other sides and configure, and let's see. we finished Dubai. We'll go to the Cairo, which is router number 2. I'll do the same way. Interface, tunnel what? Tunnel 1. Sorry. And I'll give the IP addresses 192.168.1.2. This is the IP address of the tunnel interface. And what we're gonna do? What else? Tunnel mode. GRP multi-point. IP NHRP. IP NHRP network ID 1. IP NHRP map. I'll map what? I'll map the head office here, the other sites. 192.168.1.1. The real IP 168.168.1.1. Sorry. Dot 10. Dot 10.1 here. Incomplete comma. 192.168.1.1 and 192.168. No, dot 1 here. Okay. What else? What else? If we will write also the other site, which is New York, because I'm gonna create it between these three sites, between these three sites. IP NHRP map 168.30.3. What is real IP? 192.1. I'm so sorry, guys. 1.3. And what's real IP? 192.1.30.what? 30.3. Okay. I created the tunnel interfaces. I configured the mapping. Yes. I configured the mapping. Yes, I configured the mapping. Now let's enable the routing protocol. We will configure EIGRP on the all routers and see if we can get the reachability between the private networks or not. Show first, let's see, show IP NHRP tunnel 1 created, never expired. I am here on Cairo, router number 2. Now I created the connectivity, or I have two sites. Here is Dubai and here is New York. Now let's configure the routing protocol and see. First, before I enable it, let's check if I can ping 1 or 10.3.1.3. I cannot ping it. Let's see the interfaces I got configured or not. On router 2, show IP interface pref. Okay, I have the loopback interfaces get configured here. One is 10.2.1.3 and 10.2.2.3. Tin 223 and tin here should be 2. But why 3 I'm configured over? I'm gonna change it, guys. Interface loopback 0 IP address. I'm gonna change the IP address here 1 or 10.2.2.2. Yeah, there's overlapping. There is overlapping. Yeah, first what I will do, no interface loopback 1, interface loopback 0, IP address 1 10.2.2.2, like that. That's gonna be simple. 10.2.2.2 slash 24. It will be over here. Okay, guys. Can being it? No, cannot being it. Let's go to router 1. Show IP interface brief. I need to 0 loopback. Yeah, 10.1.1.1. Fine. And on router 3, show IP interface pref. Let's see what are the IPC on the loopback interfaces. I'll find it like that. So conft no interface loopback 1 interface loopback 0 IP address 10.3.3.3. And so here 10.3.3.3. And we got it done. Now we will configure the routing protocol. On router number 1, we'll say conft router EIGRP 100, no auto summary, network 10.0.0.0 or yeah. Okay, and network 192.168, which is the tunnel interface. 192.168.10 or 1, yes, 1.0. And on router 2, we'll say exit router EIGRP 100 network 10.0.0.0 and network 192.168.1.0. Said no. router EIGRP 100. No auto summary. That is for router 2. For router 3, what we'll do, let's say conf t router EIGRB 100, network is 10.0.0.0, network 192.168.1.0, and him. Router EIGRB 100, no auto summary, in show IP interface brief. As you see here, guys, tunnel interface is up. Okay, let's see if there is a reachability or no. I'm here in New York, router number 3. I want to be in Egypt, or I want to be in, for example, Dubai. So being Dubai 192.168.1.1, which is the tunnel interface. I cannot ping it. I cannot ping it. Okay, let's see. Show IP interface brief 1.1 Bing 192.168.1.2. Why I'm not able to Bing? The reason why, because I was configure another lab here, that's why there is a conflict, guys. So I will remove the old configuration, so no router EIGRP 1234. Now let's see if I can Bing it. Bing 192.168.1.1. There is no reachability till now. So let's go one by one. Okay. Here is the tunnel 1. No IP redirect. This is IP address. This is mapping 1, mapping 2, and this is network ID. And tunnel source is this one. Tunnel mode. Sorry. So let's check. Show IP interface brief one more time. Tunnel interface is up. Okay, what was tunnel interface is up, down? Why? Why I'm not able to reach there to the other side? ID, this is the one, this is the one. Okay, this is IB. So IB network and mode is this. So that could be the problem. We can do it like that. Conf T interface tunnel 1. Shut. No shut. Let's see. Let's give it some times. Let's go to router 2, which is Cairo, and let's see the connectivity is there or no. 192.168.1.1. Even this I cannot reach. Show running config. interface tunnel 1. What is in tunnel 1 here? This is IP, the IP address. This is mapping. This is network ID and tunnel GRE mode. Show IP interface ref. It's up down as well. I'm gonna kinda interface tunnel 1. Say shut, no shut. Let's go to router 1 conf t interface tunnel 1 shut, no shut. Again go to router 3 and see show IP interface ref, still down. What is the problem, guys? Here it's very clear. Where is the source IP? I didn't configure it, so I have to write here conf t interface tunnel 1 and say what? Tunnel source. Tunnel source is what? Tunnel source. Let's go and see what is the source IP here. Yeah, it's 192.1.30.3. Tunnel source. Yeah, now it will come up. Let's go to router 2 as well and show running config interface tunnel 1. We forgot the same thing, so we'll go to the interface itself, interface tunnel 1, and say IP or tunnel source 192.1.20.2. Now show IP interface ref. Now it came up. Yeah, it came up. Let's see show IP. Show IP route. Enter. Yeah, I can see the all networks right now. Yeah, there is reachability or no? Let's see. Bing. I'll ping 192.168.1.1, which is Dubai. I'm able to ping. Let us ping 10.1.1.1. Why? Why one is not there? Let's bing 10.3.3.3. What could be the reason, guys? Do you know why? What is the issue here? The issue because I already distributed 10.0.0.0. Now this router, he got two networks 10.0.0.0.0 from that IP, from that router, and he got the same 10.0.0.0 from the other router. Now he will send a packet to this place or this place. So it's better to go to router 1 and say router exit no network 10.0.0.0 like that. What I will do, 10.1.1.0, which is better, and on the router 3 the same way, router EIGRP 100, no network, and we'll say network 10.3.3.0, like that. Let's go to router 2, conf t, router EIGRP 100, no network 10.0.0.0, network 10.2.2.2.0, like that. Let's ping right now 10.1.1.1, still. Now let's go back here, show IP interface pref cyclo run assigned. Here this is a loopback interface 10.1.1.1. Okay, let's come here, for example, show IP route EIGRP. Show IP route show IP route EIGRP. What could be the reason, guy? Why I cannot get the update of the routing on all the routes, on all the routers? It's very simple. We'll go to interface tunnel 1 and say what? And say what? What we'll say here, what we forgot here to write. Do you guys think? Here, actually, what was the problem is, if you go here and make show run interface tunnel 1, you will see that I did a map. I did a NHRB map here, multicast, and the IP of the other router, because I'm gonna make static mapping also for the multicast to lead the multicast, the EIGRP multicast mapping, or going to the, because we are using real IP as a source. So to tell the EIGRP that this is your source, actually this is your destination. This is actually the real IPs that you are going to use to inform or to make agents, the connectivity or the neighborship between the routers. That was the problem. I put this command here, IP NHRB map multicast, and I give the real IP of the other side, which is here, located in Dubai. And as well as the other sites, I did for all, for Dubai as well. Here, if you go show, I'm running config interface tunnel 1, you will find the same thing. I did it here. I put the IP here. I put the mapping here for the multicast, and I give the other sites as well. Now, if you show IP route EIGRP, you will we are able to see what? To see one. Sorry, we are in here, we are in Dubai, we can see 2 and 3, which is New York and Cairo. I can Bing as well, yes I can Bing. 10.2.2.2, yeah, it's reachable, and 3 as well. I can reach it, yeah I can reach it. So that was the issue. Even in NHRP mapping, we need a static mapping for the multicast as well to be able to reach the other side. To tell the EIGRP that you're gonna make neighborship to that side as well. Okay. Until now, we see that everything is manually done. So, is it a practical thing? I don't see that it is practical because we have to write the map between sites statically or manually. So we need to create a static mapping, which again is not scalable at all. Require all sites to have static IPs. Here we notice when we did the configuration, we see that here we do the mapping. Okay, we do the mapping actually. Sorry, guys, it should be like that. We have to do the mapping, should be like that. When we wrote NHRP or configure the NHRP, we notice that we are make the map between the real IP and the tunnel interface IP, and for all the sites. To be able to get or to reach these sites, we already configure the NHRP as manually or statically to keep the data over here, as we see here, the old configuration. So, is it scalable? Is it not? It isn't scalable at all, because as far as we adding other locations, that is not scalable. That you need to, in each site you're adding, you have to configure the NHRP statically. So in order to overcome this issue, guys, there is something called NHRP came to the picture. NHS, something called NHS. It's same idea of DNS. What do I mean by that? On the hub here, I'm gonna configure this router as NHS server, and on the spokes, spoke number 1, spoke 2, 3, all these spokes, I'll say that your NHS is this one. Your NHS server is this router. So this is your server, okay, and this is your NHS server. So once I configure it like this, what will happen? This router will register his real IP or outgoing IP and the tunnel IP on the NHS. It's gonna register himself here, and this also will register himself here, and this will register himself. So the hub will know everything about the all spokes by NHS. Once you put one command only, which it is NHS, and you put the IP of the NHS server or IP of that router, it's gonna register himself here in NHS. So let's see it how it is done or how it is configured. Here I'm gonna clear the old configuration that I did. No interface tunnel 1. Here as well, conf t, no interface tunnel 1. Here, no interface tunnel 1. I already deleted the whole configuration, all tunnel interfaces. I have to do what else? Let's remove the EIGRP. Yes, no router EIGRP 100. Remove it from 2. No IP router EIGRP. No router EIGRP 100. And on the router 3, no router EIGRP 100. So I deleted all the configuration I did. Now let's see how it is configured. On the master, or you can say on the that router 1, which is Dubai, what I will do, I will configure interface tunnel 1. Then I'm gonna give I'm gonna give it address 168.1.1. IP address. Yeah, this is the IP address. Then tunnel source. What is the tunnel source here? Tunnel source 192.1.10.1. Sorry. .1. Yes, this is the tunnel source. And tunnel mode GRE multi-point. Yes, like that. And IPNHRB map multicast. Here we can make it dynamic like that. Yes, dynamically it's gonna get the mapping of the multicast IP addresses. Exit. I'll configure the routing protocol EIGRP. This is actually the master, which is gonna be the NHS router EIGRP 100 network, no auto summary, no, or network 10.1.1.0 and network 192.168.1.0, like that. Okay, as you see the configuration here, we just said that tunnel the IP address, we created the tunnel interface, we give it address, and tunnel source, and what else? IP NHRP is IP NHRP IP NHRP network ID. This is what we interface tunnel 1 IP NHRP network ID 1. This is NHS. What about the other routers? What we will do, we'll create tunnel, and we'll give it an address, IP address 192.168.1.2, and we'll say tunnel source 192.120.2. This is a tunnel source. And what else? Tunnel mode. Tunnel mode is GRE multi-point, and IP NHRP network ID 1. Here, here the NHS IP NHRB NHS 192.168.1.1. This is my server actually, and IP NHRP map 192.168.1.1 192.1.10.1, the mapping as well. And IP NHRP map multicast 192.168 yeah. We have done it. Yes. We'll configure the routing protocol in it. Yeah, we'll configure the routing protocol on it. We'll say router EIGRB 100, no auto summary, and network 192.1.0, network 10.2.2.2.0, and show IP route EIGRB 100. Let's see the tunnel interface. Show IP interface brief. The tunnel interface is still down. What could be the reason here? Show running interface tunnel 1. What could be the reason here? We'll see. This is IP address that I have given this IP NHRB map. This is a map actually, and here IP NHRB map multicast, IP NHRB network ID, and IP NHRB NHS the IP. Here the tunnel source is wrong. I have conf t interface tunnel 1. I'll say no. Then I'll write it again. Tunnel source. What is the IP? 192.168 dot I'm sorry, 1.20.2. Now it should be up. Show IP route EIGRB. Yes, now I got it. We can ping the head office, one being 10.1.1.1. Yeah, I can ping it. Let's go to the router. Which router? Router 3. We'll create conf t interface tunnel 1, IP address 192.168.1.3 to 55.255.0, and we'll say IP NHRP. Network ID is 1. IP NHRP source tunnel mode GRE multi-point tunnel source 192.1.30.3. This is a tunnel source. IP NHRP NHS 192.168.1.1. IP NHRP map multicast 192.1.10.1. IP NHRP map 192.168.1.1 192.1.10.1, and we have done it. Now we'll configure the EIGRP router EIGRP 100, network 192.168.1.0, network 10 dot, what is IP 333, sorry 0. We have done it. Let's see, show IP route. EIGRP, yes, I got it. Let's ping it 192. Sorry, let's ping 10.1.1.1. Yeah, I have reachability right now. This is NHS. Okay. And instead of writing the static mapping as we did in the previous phase, now we have NHS, and NHS can get to all other sites. The other sites, once I put the command NHS and the IP of the site, it's gonna register the IP of NHS server. All the other routers gonna register the real and the tunnel interface IP addresses on it. So this is the way. But right now, what is till this point, what is actually you notice here when you say show IP route EIGRP? If you notice here, we are right now on which router? Router number 3, which is located in New York. Okay. But guys, if I want ping 10 dot what? If I want to ping 10.1. Sorry, I want to ping 10.2.2.2. Is it possible to ping it? I cannot ping it right now. Why? As you notice here, I cannot ping it. Why? Can you think why? I'm right now, I want to ping here, but I cannot ping it. If you guys remember the behavior of EIGRP routing protocol, split horizon, because this router is not directly connected to this router, and this router is not directly connected to this router. This both routers has connection only to the hub. This is spoke routers connected directly to the hub. We connected to the hub like that, and we connected to the hub like that. So the behavior of EIGRP split horizon, if you guys remember, Dubai is receiving the update, the routing update from this router on this interface and receiving as well the update from this router on the same interface. So what is the behavior? This router, once he receive the update from this router here, will not send it back to the other. He will not send it back on the same interface. Yani, once he receives the update here on this interface, he will not send it back on the same interface to the other routers. So the routing or the routes will be stopped here. That is the way of split horizon to prevent the loop. To overcome this problem, what we can do, we can go to Dubai, which is the head office or the hub, and say what? We can go to the interface tunnel 1 and say no IP split horizon EIGRP 100. No IP split horizon EIGRP 100. Once you do it, if you go down to New York, show IP route EIGRP, you will find what? We can reach it now. Ping 10.2.2.2. Yeah, I can reach Cairo. Yes, I can reach Cairo. Amazing. But another observation, what it is, if I trace route to 10 dot if I trace route 2.2.2.2, I am right now in New York and I want to reach Cairo. What is actually, how it is the journey from New York up to the Cairo, what is the route, how the packet is gonna come here? Is it gonna come here directly, or it will take something in the middle, then it will go to here? Let's see. As you see, guys, it will go to the Dubai first, then it will go to Cairo. So it will be like that. And as you see, it's not something good. To solve this issue, what we can do? We can go to the hub, itself, and tell to the hub what? No IP next hop self EIGRP 100. In this case, the first packet will go to the hub, the second one will go to directly to the, and let's see trace route how after we made this change, we put this command no IP next hop self EIGRP. We'll say trace route 10.2.2.2 directly. We can reach it directly right now from New York to Cairo. Okay? Amazing. Now spoke to spoke. Not spoke, hub, spoke. No, now it's spoke to spoke. Spoke router can speak to spoke router. Good. This is actually phase 2. Phase 3 we can overcome it on another way. How does it happen? You can go to here, to the hub. What you will say to the hub? You can go to the hub and say IP NHRP redirect. Any traffic comes to you from the spoke, please redirect it. Once you he will not redirect it, he will send this one. He will send if this guy want to, for example, if this guy want to come here, okay, this one will send him a redirect packet. Tell him that if you need to speak to router 2, go to it directly. And I will let router 3 listen to this packet, that's okay, redirect packet. How can I make this router listen to redirect packet? I will tell to the spokes tunnel 1 IP NHRP what shortcut. This is on router 2 and router 3 as well. Interface tunnel 1 IP NHRP shortcut. Now any packet will go direct to the spoke to spoke directly, and this is phase 3. Now I want to remove the EIGRB and use OSPF. No exit, no IP route, EIGRB, sorry, no router, EIGRB 100. I remove the routing protocol from all of them, from 1, from 2, and from 3. And I will replace it with OSPF. I will say IP route OSPF, yeah, IP route, not IP route, why it's taking my mind, okay, router OSPF 1 router OSPF 1 router OSPF 1 and network what 192.168.1.0 .0.0.255. Sorry, you have to mention the area 0 and 10 as well. 10.1.1.0 like that. This is for router 1. For router 2, router OSPF 1 network 192.168.1.0 area 0 and 10 10.22.0 This is for router 2, router 3, router OSPF 1, network 192.168.1.0, 0.0.0.255, area 0. Network 10.0.0.0, oh sorry, 3.3.3, oh, 0, and 0.0.0.255, area 0. What's going on here? Makes it change to down. Oh my god. Okay. And here show IP route OSPF. Show IP interface brief. Yeah, tunnel still up, but what happened here? This is actually adjacency. What's going on here? Conft. Let's see what's going on the router 2 and show running config section OSPF. So I have an observation here. What is actually, once you enable OSPF on the tunnel or with Dmvpn, once we enable it, we enable OSPF, we'll find that the OSPF is dealing with MGRE multi-point as a point-to-point circuit. He will deal with the MGRB multi-point. As you see here, we have multiple point, but once you configure the OSPF, you will find it deal with the network or the network type. OSPF is gonna be point to point, so you have to change the behavior of OSPF from point to point to either broadcast type or point to multi-point. But if you change it to broadcast, you have to change the ID of here on the hubs, sorry, on the spokes. You have to change the ID, the priority. You have to change the priority. If you configure the network type, OSPF network type as a broadcast, you have to change the priority into 0. Why? Because of the DR and PDR election. Fine. So this is a configuration exactly. Let's show it to you. Show IP show running config section OSPF, and here on the spokes, as you see here, the IP OSPF priority is 0, and I change it here. This is the configuration of the OSPF, and show running config interface tunnel 1. You will find here that I converted the network type, IP OSPF network type, from point to broadcast. Yeah. Here we, as you see, that the traffic, when it goes from or between these locations that I already connected them through Dmvpn or multi-GRE, we will notice that the traffic itself is going to be in a clear text. So we need to do what? We need to configure IPsec to encrypt the data between them. You guys remember that when we configured the IPsec in the previous videos? Yes. It's very easy and very simple. We'll go through phase 1, phase 2. Then we'll make the profile and we'll attach the profile to the interface. Yeah, so let's do it. So guys, I'm gonna do it on these two sides, and you can make it the other sides. Okay, I'll make it between Dubai and Cairo, and you can continue. So let's do it. Yeah, on the route to 1, what we'll do, conft crypto ISACAM policy 10. If you remember, guys, key encryption and hashing. What is the key I'm gonna use? I'm gonna use pre-shared key. What is the hash? MD5. Key encryption. What is the encryption I'm gonna use? I'm gonna use 3DS. Key encryption and hashing. Exit. Crypto key. ISACAM. IPsec. So ISACAM, yeah. ISACAM key. Cisco 1, 2, 3. These are the steps that we mentioned before. And what is the IP address of the other side? 192.1.1 dot what? I am now in Dubai and I want to connect to Cairo. So 192.1.20.2. And after that I write what? Here you have to mention address like that. Second phase, crypto IPsec transform set ESP transform set, and you give it a name. We'll give it ABC and the encryption hashing. I forgot one thing, guys. Can you remind me? Let me write this line, then I will write again. I will go back to the ISACAM, the first phase, because I forgot to group 1 or group 2 the Diffie-Hellman. So crypto IPsec transform set ABC ASP what? So yes. Okay, and ESP what? MD5. Fine. You guys, I'll get back to crypto map. ISACAM policy 10. Group 2 I'm gonna use. Then exit. Now I'm gonna create the profile IPsec crypto key crypto IPsec profile. I'll give it a name. IPsec profile. Then I'll give a set, transform set, and the name of the transform set. Then I will go to the interface. What is the interface? Interface tunnel 1. Yes, and I will apply it. I will say what on the tunnel protection IPsec, tunnel protection IPsec, yeah, tunnel protection IPsec profile what iprof. Now it's on. We'll make it on the other side. Yeah, we'll make it on the other side as well. We'll go to the other side, but we end show running config section crypto, enter. We can take copy from here. Yes, crypto as account policy, encryption, hash, authentication group, crypto as account. So you know guys what I'm gonna do. I'm gonna open Notepad here. Yeah, I will take this copy here like that. I'll put it here. This is phase 1. Yes, guys. Then transform town. Here, as you remember, the mode is town. We are gonna change the mode into what? We're gonna change the mode to transport, if you remember, guys. But I'll make it later. Crypto IPsec profile, iProfile, set transform set IPC. Yeah. We'll go take copy. We already finished 1. We'll go to 2. Paste it. Yeah, everything is nice. So exit. Interface tunnel 1. What? IPsec, tunnel protection IPsec profile iprof. Yeah. Clear? Yeah. ISACamp is on right now, and you can encrypt the data. But from the last video, if you remember, that we already made something here. Do you guys remember the outer header and the inside header, the header of the ESP and the header of the GRE? GRE is using which IP actually? 192.168 dot is using what actually? Is using 1 as a source, 10.1, and destination 192.168 dot dot 1 dot 20.2. This is source, this is destination of what? That is used by GRE. and is used as well by ESP, as you guys remember. So to get rid of or to reduce the packets, the size of the packet, what we will do, we'll change the mode to transport. Once we change it from tunnel, as you see here, the mode is tunnel, we change it to transport, it's gonna remove this and it will keep the ESP of source and destination only. Yeah, so let's do it. We'll go to router 1. What we'll say, conft, and we'll take this command here, and instead of tunnel we'll make it transport. I'll take a copy. On router 1 and router 2 as well, like that. Alright? Yes. This is for you guys, but if you notice here in the configuration, when I configured the tunnel as protection, if you guys see here, and if you guys show running config, I think there is no need for transport to be configured right now, because you know why? If you show running config interface tunnel 1, what you notice over here, you see tunnel protection IPsec profile iBref. It means that this is actually IPsec mode and IPsec mode. That means that it is what? It is native IPsec. It is native IPsec interface here. So once you configure it like this, tunnel protection IPsec profile, it's gonna get rid of GRA as well, encapsulation. So it will be the ESP only, IPsec only. Till here we finished Dmvpn and MGRE, and see you in the next series.